This is examples in music for Module 51. Objective 51.1 says calculate the inversion of an ordered pitch set. Objective 51.2 says calculate the inversion of a pitch class set. Let's listen to this piece for piano by Bartók, and then we'll do some analysis. For these two objectives, which focus on ordered pitch set inversions and inversions of pitch class sets, we will use the sets found in the first two measures of the right-hand line, the G, A, B, B flat, C, followed by the C sharp, B, A, B flat, A flat. Here I have the first measure of the right hand, and here I have the second measure of the right hand. In integer notation, this translates to 79ET0. In integer notation, the second measure translates to 1E9T8. Objective 51.1 says calculate the inversion of an ordered pitch set. These are both ordered pitch sets because we are listing the integers in the order that they appear in the piece. For two ordered pitch sets to be related by inversion, they would have the same size intervals between each integer, but with the direction reversed. If we analyze the ordered intervals between these pitches, we'd see in the first set we have +2, +2, -1, +2. In the second set, we have the same intervals with the directions reversed. -2, -2, +1, -2. Therefore, these two pitch sets are related by inversion. In the exercises for 51.1, we ask you to calculate the inversion of a given ordered pitch set. And for those exercises, we instruct you to start the inverted pitch set on the same starting pitch as the original set. However, as you can see here, two sets can be related by inversion even if they do not start on the same pitch. What matters in this case are these numbers, that they have the same ordered interval sizes, but the directions are reversed. 51.2 says calculate the inversion of a pitch class set. Remember, a pitch class set is simply made up of the integers, but we don't necessarily care about the order that they appeared in the piece. There are several ways to calculate the inverted set of a given pitch class set. The first method is to find the inverse integer of each pitch class in the set. You do that by looking at each pitch, and the resulting pitch would be the one in which the sum equals 12. The inverse of 7 is 5 because they would add to 12. The inverse of 9 is 3, they would add to 12. The inverse of E is 1. The inverse of T is 2. And the inverse of 0 is 0. A second method is to find the number on the opposite side of the clock face from the original. If we look at the first number 7 on the clock face and draw a straight horizontal line to the other side, it lines up with 5, its inverse. If we look at the number 9 and do a straight horizontal line across the clock face, we get to number 3, its inverse. 11 lines up with 1, T lines up with 2, and 0 is its own inverse. Therefore, the inverse of 7, 9, E, T, 0 is 5, 3, 1, 2, 0. You may ask the question, if 5, 3, 1, 2, 0 is the inverse of 7, 9, E, T, 0, how does that work if we said the two ordered pitch class sets up here are related by inversion? First, let's look at the pitch class set 5, 3, 1, 2, 0. And for a moment, let's determine the ordered pitch intervals between these integers. 5 to 3 would be -2, 3 to 1 would be -2, 1 to 2 would be +1, and 2 to 0 would be -2. So, from our previous definition, both this set and this set meet the requirement of the same size intervals with opposite directions. In fact, we can take 5, 3, 1, 2, 0 and get to 1E9T8 if we add 8 half steps to each integer using mod 12 arithmetic. 5 plus 8 equals 1. To confirm on the clock face, start on 5, add 8. 1, 2, 3, 4, 5, 6, 7, 8. We arrive on 1. 3 plus 8 is E. 1 plus 8 is 9. 2 plus 8 is T. 0 plus 8 is 8. And we arrive at the set that appears on the piece. Therefore, while 1E9T8 is not the direct inversion of the pitch class set 79ET0, it is related by inverse to the original set, but also there's a transposition involved of 8 half steps. In fact, you can have many different transpositions that are related to your original set by inversion, and we'll be covering that in later objectives. A heads up though, if you are wanting to calculate sets that are related to an original set by inversion and transposition, make sure you do the inversion first and the transposition second, or else it will not work. There's also a third method to creating an inverted set. This one involves ascending order and using something called the rainbow method for inversion. For the sake of analysis and discussion, it is often helpful to have both a pitch class set and its inversion, or what we learned earlier is called the normal order. To use this method, first place your original set in ascending order. Whereas the original set was 79ET0, ascending order would be 79TE0. Similar, but the T and E are now interchanged. Now, start with the last number of your set and find its inversion and place it as the first number of the new set. The inverse of 0 is 0. Now go to the second to last number, find its inversion, and place it as the second number of the new set. The inversion of E is 1, and so on. The inversion of T is 2, the inversion of 9 is 3, the inversion of 7 is 5. This is called the rainbow method because if we traced the arcs of the related numbers, they would make something that looks like a rainbow. Notice that the integers in the inversion set are the same as the integers here, but now they are already in ascending normal order.